This one's straightforward. Molar mass of calcium acetate. You add up 1 calcium at 40.08. There are 4 carbons, each weighing 12.01. 6 oxygens, or excuse me, 6 hydrogens at 1.01 each, and 4 oxygens each at 16. When you multiply and add those together, you get 158.18 grams per mole. To calculate the number of moles in 17.2 grams of benzene, C6H6, well, you have to look at the molar mass. There are 6 carbons, each at 12.01 each. There are 6 hydrogens at 1.01 each. So if you add those together, you find out that it has a mass of 78.12 grams in 1 mole. Grams cancel, divide, you end up with 0.220 moles of benzene. Similar type problem. Okay, this time you have 0.187 moles of tin 2-sulfate. Okay, well, you have to say, well, for every 1 mole of tin 2-sulfate, if you add up the mass of 1 tin, 1 sulfur, and 4 oxygen, you get 214.78 grams. Moles cancel, multiply, and you get 40.2 grams of tin 2-sulfate. Okay, to calculate the number of molecules in this amount of water, the first thing you realize is that mass and molecules are not related. But mass and moles are related, and moles and molecules are related. So you must use that intermediate step of the mole. 2.96 grams of water. Well, how many moles is that? I know that 1 mole of water weighs 18.02 grams. Grams cancel. And I know that every 1 mole is 6.02 times 10 to the 23rd molecules, by definition. So if I take 2.96 times 6.02 EE23 divided by 18.02, you get 9.89 times 10 to the 22nd, the unit molecules. This is very similar to the last problem, except for this time you're starting with molecules, 7.13 times 10 to the 22nd molecules. Well, the first thing I have to do is I have to change that to moles. And I know that for every 1 mole, there are 6.02 times 10 to the 23rd molecules by definition. Molecules cancel. I now know moles, except for I don't want moles, I wanted grams of CO2. But I know for every 1 mole of CO2, it has a mass of 44.01 grams. 1 carbon and 2 oxygens. Moles cancel. I multiply 7.13 times 10 to the 22nd times 44.01 divided by 6.02 times 10 to the 23rd, and you should get 5.21 grams of carbon dioxide. Calculate the volume of 5.18 moles of oxygen gas at STP. This is an ideal gas law problem. PV equals nRT. So let's see, standard pressure. Let's just use 1 atmosphere. The volume is what we do not know. Let's see, we know the number of moles. It was given 5.18 moles. The value for R, the gas constant, has to be 0.082 atmosphere liter per mole Kelvin. And then standard temp, 273 K. Squeeze that in there. Now to solve, if I divide both sides by 1 atmosphere, atmospheres cancel, moles cancel, Kelvin cancels, I'm left with liters. That's outstanding. 5.18 times 0.082 times 273, all divided by 1, and you get 116 liters. The law of conservation of mass states mass is neither created nor destroyed in any chemical or physical reaction. It is in fact conserved. Okay, the following balanced equation, we have hydrochloric acid and oxygen turning into water and chlorine gas. To interpret the number of atoms or moles, the coefficients really represent the mole ratio of all the elements. So for every 4 moles of hydrochloric acid, you get 1 mole of oxygen, produces 2 moles of water and 2 moles of chlorine. You could also use that as individual atoms or molecules. Now the mole ratio of oxygen to chlorine is 1 to 2. For every 1 oxygen, there are 2 chlorine. And then how many moles of chlorine can be produced from 3 moles of oxygen? Well, start with 3 moles of oxygen. According to the balanced formula, for every 1 mole of oxygen, you have 2 moles of chlorine. That cancels. 3 times 2, the answer, 6 moles of chlorine. Okay, the first thing you have to do with this problem, you have to start with what you know. I know that I have 15 grams of magnesium, and I'm trying to get to grams of hydrogen. And so the first thing I must do, okay, so there's your 15 grams of magnesium, you have to convert to moles. So you can use the mole ratio. For every 1 mole of magnesium, it weighs 24.31 grams according to the periodic table. Grams of magnesium go away. Now, from the balanced formula, I know for every 1 mole of magnesium, there is 1 mole of hydrogen. Okay, however, it didn't ask for moles of hydrogen, it asked for grams. So I know for every 1 mole of hydrogen, it has a mass of 2.02 grams of hydrogen. Moles cancel. Multiply 15 by 2.02 divided by 24.3, and your answer, 1.2 grams of hydrogen. Okay, what volume of carbon dioxide will be produced when you have 15 grams of, that's propane, and it's burned completely, forming carbon dioxide and water. So, start with what you know once again. So we have 15 grams of propane. All right, and I know that every 1 mole of propane has a mass of 44.11 grams. Okay. Grams of propane cancel. Now that I know the moles, I can do my mole ratio from the balanced formula. For every 1 mole of propane, I have 3 moles of carbon dioxide. Okay, and so now, if I solve this, this will tell me how many moles of carbon dioxide I have, and I have 1.02 moles of CO2. Okay, now I know that this is at STP, and so what I can do is I can use the ideal gas law, PV equals nRT, to solve for the volume of carbon dioxide. And because of the standard pressure, let's just use 1 atmosphere. That's an easy one. The volume I do not know. Number of moles we just solved for. The gas constant is 0.082 atmosphere liter per mole Kelvin. I'm running out of room. Just understand this 273 Kelvin goes up there. It's not on the denominator. So basically I'll multiply 1.02 times 0.082 times 273 divided by 1, and then your answer should be 22.8 liters. Okay, very similar type problem to the last one. Start with what you know. 4.25 grams of aluminum. We have to convert this to moles. 1 mole of aluminum has a mass of 26.98 grams. Grams cancel, I now know moles. According to the balanced formula, for every 2 moles of aluminum, I get 1 mole of hydrogen. Moles cancel. Multiply and divide, I get 0.0788 moles of hydrogen. Okay, now that I know the moles of hydrogen, I can apply it to the ideal gas law, PV equals nRT. Once again, this says at STP. So 1 atmosphere pressure, I do not know the volume. I know the moles, as we just solved for that, 788 moles. The ideal gas constant, 0.082 atmosphere liter per mole Kelvin. And then finally the temp, 273 K. If I want to solve for this, if I divide both sides by 1 atmosphere, multiply and divide, you end up with X is 1.76, the unit liters. Alright, this is a limiting reactant stoichiometric problem. How do I know? I have 2 starting amounts, and it wants to know the amount of product that can be produced. So what I'm going to do is I'm just going to do 2 calculations and look for the smallest result. Okay, for every 1 mole of sodium hydroxide, it weighs 40 grams. Grams of sodium hydroxide go away. According to the balanced formula, I know for every 2 moles of sodium hydroxide, I get 1 mole of sodium sulfate. And then I want to do mass. I know that 1 mole of sodium sulfate happens to have a mass of 142.05 grams. Moles cancel. And so this, if I do the calculation, I get 71.0 grams of sodium sulfate. Is that my answer? I don't know. So I have to do the other calculation. So I'm going to do the same thing. 60 grams of sulfuric acid. Okay, I know that every 1 mole of sulfuric acid has a mass of 98.09 grams. Okay, and what I'm going to do now, grams cancel. Okay, from the balanced formula, I know for every 1 mole of sulfuric acid, I get 1 mole of sodium sulfate. Moles of sulfuric acid cancel. Once again, 1 mole of sodium sulfate still has a mass of 142.05 grams. Moles cancel. If I do this calculation, you're going to find out that it equals 86.9 grams. And so it's the smaller of the two, the 71 is your result. This is another limiting reactant stoichiometric problem. Same thing. We start out with 3.2 grams of aluminum. I know that for every 1 mole of aluminum, it weighs 26.98 grams of aluminum. Grams of aluminum cancel. According to the balanced formula, for every 2 moles of aluminum, I get 2 moles of aluminum chloride. Moles of aluminum cancel. I want to find the mass of aluminum chloride, so 1 mole of aluminum chloride has a mass of 133.33 grams. Moles cancel. Multiply and divide, and you get 16 grams. I'm going to do the exact same thing for the 5.4 grams of chlorine. Well, I know that 1 mole of chlorine weighs 70.90 grams. Chlorine, it's diatomic. Okay, and then according to the balanced formula, for every 3 moles of chlorine, there are 2 moles of aluminum chloride. Moles of chlorine go away. 1 mole of aluminum chloride has a mass that's still 133.33 grams for every mole. Moles cancel. When I solve for this, I get 6.8 grams of aluminum chloride. That's the smaller amount. That's your result.